Energy Switch is the popular point-counterpoint show where two leading experts with different perspectives discuss the most pressing energy and climate issues in the news today. Coming up on Energy Switch, the challenges and opportunities in recycling plastic.
Funding for Energy Switch was provided in part by the University of Texas at Austin.
We use plastic for almost everything: clothing, car parts, medical devices, electronics, and especially packaging. Plastic is everywhere, meaning it's increasingly in our oceans, our water, our food, even our bodies. That's because, as with everything, the many benefits of plastics come with challenges. In this case, disposal and recycling. We'll talk about this and plastic's energy and emissions footprints with two experts. Holli Alexander. She's a Strategic Initiatives Manager for Plastics Recycling at Eastman Corp., on the Board of Directors at the Recycling Partnership, and Chair of the Board at the Plastic Pact.
Plastic recycling is not a myth, but we could absolutely do it better. And as we look at this, looking at infrastructure improvements, looking at technology additions that can add complementarity and additionality to the system are going to be critical so that we keep these molecules in loop.
Anja Brandon is the Associate Director for U.S. Plastics Policy at the Ocean Conservancy, formerly a U.S. Congressional Science Fellow with a bachelor's, master's, and PhD from Stanford.
When we think about really what's driving our plastic pollution crisis or the waste crisis that's impacting recycling, we're talking about single-use plastics. We know that nearly half of the plastics produced each and every year are for packaging. Your straws, your plastic bag, bottles.
I'm Scott Tinker, and I'm an energy scientist. On this episode of Energy Switch, the energy and climate footprint of recycling plastic.
Let's just kick right into this topic. Why do we care? Why should our listeners even care about plastic?
There's no hiding the fact that we are in the middle of an absolute plastic pollution crisis. Whales are washing up on the shore with plastics in their belly. Turtles can't really make it through the ocean without getting impacted by plastics. And more than that, we know we are ingesting plastics through microplastics, through the air we're breathing, the water we drink, and the food we eat. I think we've often been caught in this frame of it's an either-or decision. We either need to reduce everything or recycle everything. And much like the climate crisis, it is long past time of this being an either-or option. We absolutely need to do both.
Yeah, so I shouldn't reach down and get my plastic cup and have a drink right now. It just made me never want to do that again. Holli, anything to add to why we should care?
I think the plastics are such an interesting challenge because there are obviously some really significant environmental concerns. We have some absolutely emerging human health concerns. And as we think about these different materials, it's really, really critical to start to try to understand why are we using them in the first place.
Sure.
We have a lot of opportunities, I think, to make things better, to still get the benefit of these materials.
Yeah. What are the benefits of plastic to begin with? What do we use it for?
So plastics go into almost everything. About 60% of clothing is made of plastics, carpet in your home, all kinds of piping and things that we use to move water. We have it, of course, for packaging. It's an incredible tool to help to prevent spoilage of food, but also medical devices, going into medical packaging, things that need to be sterile so that we can be safe with those procedures.
I'd like to jump in on this. A lot of those applications that, Holli, you just mentioned are not what's driving this crisis. When we think about really what's driving our plastic pollution crisis or the waste crisis that's impacting recycling, we're talking about single-use plastics. We know that nearly half of the plastics produced each and every year are for packaging.
So my straw.
Your straws, your plastic bag, bottles.
Interesting.
So when we as policy makers or environmental advocates are trying to move the needle and really tackle this crisis, that's really what we're targeting.
How much do we make each year? Just give me a sense of some volume or weight that our listeners could understand.
There's not a lot of transparency or data out there. In terms of production, it often gets lumped in with other petrochemicals, which includes things like fertilizers. And we know the vast majority of petrochemicals go to plastic, but we don't know exactly how much.
That's not required reporting? Or?
It's not.
It's not.
Really?
It's not right now.
Interesting.
No.
So do you have a feeling, just ballpark, something?
Each year we end up with about 350 million tons of plastics that are waste, plastic waste that's being generated.
350 million tons, 700 billion pounds. That's incredible.
The trick with those waste numbers is that they're modeled estimates, right? We don't actually have the data on how much we're making, where it's going, how much we're recycling, how much is actually getting reused.
We being the world, or the U.S. doesn't?
Both.
I'm really surprised by that. I didn't know that.
Yeah.
So let's bring it into kind of the energy and climate perspective on this. Just give me a feel for how much energy we use in the U.S. to make plastic.
So according to a study that was done by NREL, you end up looking at about 3.2 quadrillion BTUs of energy a year in the U.S. To manufacture plastics.
NREL is National Renewable Energy Lab.
That is it exactly.
And we use about 100 quads a year. I'm an energy guy, so that's about 3%, 3 to 3.5%. That's a lot.
It is.
That's a lot. Climate footprint.
Plastics are a fossil fuel. Plastics are made out of oil or gas. They use coal as energy. If the plastics industry was a country, it would be the 5th highest greenhouse gas emission polluter in the world. So it's responsible for 3 to 4% of all greenhouse gas emissions each and every year.
That doesn't include the disposing or recycling. Is there more energy used to do those things?
Absolutely. So for example, if you incinerate plastics, you are releasing all of that carbon just as if you were, using gasoline in your car, coal or oil in a power plant, and you're losing the material. So you then have to go back to fossil fuels to remake that plastic.
Do people burn it?
We incinerate about twice as much plastics in the U.S. as we recycle at the moment.
Are we the only country doing that?
Absolutely not. We are on the lower end of that spectrum.
Okay.
And incineration, sadly, is projected to increase around the world as countries continue to ramp up their use of plastics.
What kind of crap does that put into the air?
Great question. We know in addition to all of the greenhouse gas emissions, it is emitting toxins that are used in the production of plastic, like PFAS, dioxins, particulate matter, as well as heavy metals that are often used as the catalyst for plastics.
What do you got there?
One thing that's really important with this too is that you've got kind of two different options quite often with plastics at the end of life. And I think in some cases you're seeing incineration being used as a viable option because of concern about plastics being leaked into the waterways and all of this. And that's not necessarily taking us in the right direction.
So if we're not burning, how much do we landfill, just on average? Or
In the U.S., we landfill about 75% of plastics.
75% landfill. How much was incinerated?
About 15 to 16.
That leaves just 10%.
Less than 10% gets recycled, yes.
Interesting.
And none of that accounts for...
That's a lot of headroom then for recycling.
Absolutely. And none of that accounts for what we know ends up in the ocean. For decades, we sent our waste overseas to be recycled. We've done studies. When we take into account how much we exported overseas and what ended up being mismanaged there, the U.S. ranks as high as 3rd in terms of countries contributing to our ocean plastic pollution crisis.
One thing, though, I think that's really important to note is we're processing domestically now about 90% of the material that's collected in the U.S. That is up from only 60% that was processed domestically in 2010. So hopefully we can avoid shipping materials overseas, especially when you don't have visibility in how those materials are going to be used.
Tell me the kind of extent of impacts from ocean plastic.
I mean, how long do we have? To give you a rough estimate.
We'll edit you, don't worry. No.
To give you a rough sense of it, about 11 million metric tons of plastic enter the ocean every single year from land-based sources alone. That's more than a garbage truck's worth of plastic entering the ocean every single minute. Once out there, we know it's absolutely devastating.
Yeah, as a geoscientist, I am just picturing the ocean's circulation systems moving things around. I imagine there's some concentration centers.
We call them hot spots, absolutely. And where the ocean flows really does impact the plastics we see on the surface, but we know it's spread throughout the entire water column. We know that what happens in the ocean impacts our climate and how we can be resilient to additional changes, and there's growing levels of concern about how plastics are going to impact that.
Interesting. Well, let's get into it. Let's get into recycling a little bit. What are the challenges there?
The challenge is that we have over 9,000 different recycling programs in the United States.
Yeah.
We have a privatized system that is variable. You can move 3/4 of a mile down the road, and now all of a sudden you have a completely different set of materials that you can or cannot put in your bin. And we've also only got, about 60% of Americans have access to curbside recycling.
Yeah.
And that's even less for folks who live in multifamily homes. So we have a lot of opportunity, but a lot of challenges, I think, that go along with plastics.
So make me feel good for a second. We dutifully toss into the same bin
Yeah.
aluminum cans
Yeah.
and plastics and some paper. Does it get recycled, really?
It does.
It does.
It does. So yeah, recycling is real.
Okay.
We have about 5 billion pounds of plastics that are recycled annually in the
5
United
billion.
States.
Yeah.
We do what's called single stream recycling. And that's what you described, where you put all your metals, your glass, your fiber, and your plastics all together in one bin.
Right.
And then the plastics generally are then sorted into 2 different types of materials, usually for high density polyethylene and PET.
Okay.
And then those get sold onto the market and go into brand new applications.
Interesting. So it's a real industry.
According to the Association of Plastics Recyclers, about 200,000 people have jobs due to plastics recycling in the U.S. alone.
Talk more about it.
Yeah, we should start with the fact that we can improve recycling across the board in this country.
Yes.
And there's no hiding the fact that plastics are currently performing the worst. They're the least recycled material. And I'm going to take us back to high school chemistry for a second to explain why.
Good.
Break.
Those numbers that Holli was talking about, that little number 1 if you flip over your water bottle, or number 5 if you look at a yogurt tub, those are fundamentally different. Those are chemically different at the molecular level. So unlike your aluminum can, which might be the same aluminum as your aluminum foil, we need to separate out those materials. And then you add color and format and labels and toxic additives, and it becomes a lot more challenging to sort and recycle.
What are the main recycling processes that we see today?
What the recycling process has been historically up till now has been mechanical recycling. You're essentially going to take those containers that are like each other, chop them up, wash them, melt them, and turn them into something new. Chemical recycling is a comprehensive term that refers to several different types of technologies. But at a high level, the goal with chemical recycling is to take polymers and break them back down into their constituent building blocks.
Okay.
And then from that, you can remove contaminants and additives and then rebuild those back into useful materials.
So we're chopping them up chemically into very little things.
Basically, yeah.
instead
So
of-
breaking some of those molecular bonds and then going back to, essentially the molecules that we used.
Thoughts on that? Things to add?
Yeah, I think the 2 main types of chemical recycling technologies we're building out right now, we generally think of as conversion chemical recycling technologies. These are things like gasification and pyrolysis. These are converting our plastics into crude oil with respect to pyrolysis, or synthetic gas when it comes to gasification.
Right.
These are incredibly energy-intensive processes. We're talking up to 100 times more greenhouse gas emissions than mechanical recycling. So you have to put a ton of energy in to get out a very crude product that has to then go back to being a fossil fuel.
Right.
The vast majority of which is actually used for energy because it ends up being pretty crude still. So it's not necessarily going back into plastics. So the term chemical recycling is really false advertising.
Interesting.
Definitely want to go back to the chemical recycling
Right.
side. So Eastman, as a raw material supplier, we see this as a great opportunity for us as an organization to start to decouple some of our production from virgin fossil fuels. And as we're looking at this, we're looking at 2 different technologies. One is around gasification, which is one of the technologies that Anja just mentioned, but we also are doing some work in methanolysis. Really importantly, I think on the gasification side is Eastman's made a really firm commitment that we are not going to engage in any of these technologies if we do not see an improvement over virgin manufacturing. If it's not better than virgin from, let's say, a climate standpoint and emission standpoint, then why would we do it, right?
Gotcha.
So with gasification, we're producing synthesis gas. But for our technology, we're looking at about 80% improvement in terms of greenhouse gas emissions associated with synthesis gas coming from plastics versus virgin fossil fuels.
Interesting.
And that's been a really important consideration. Methanolysis is one that's focused on polyester-based waste. So whether it's the PET clamshells that a mechanical reclaimer doesn't like, or let's say opaque or colored PET packaging formats that are out there.
Okay.
But also polyester-based clothing or polyester-based carpet, we can process those together and we'll break those back down into their constituent parts. We can then take those, put them back together, and make brand new polyester-based plastics that are indistinguishable from prime. And so this gives us a chance to create an option for those materials that aren't good candidates for mechanical recycling and bring them back into the system and create a circular economy.
I will say a meta review that came out by the National Renewable Energy Lab, so NREL, so a review of all of the science that's been done on this so far found that pyrolysis and gasification are 10 to 100 times worse in terms of economics and environmental impacts than virgin polymers.
This is the whole education process of nothing is perfect. You know, that all these things require earth materials. We make stuff, we dump it, the atmosphere otherwise, we do it over and over. So what we're really talking about here is how to do that just much, much better, right?
Yeah, I mean, to really break out of that cycle, we first need to reduce. You know, if we think back to our little chasing arrow triangle, we have reduce, then reuse, then recycle. So recycle should be the last option we're thinking about. And in terms of plastics and plastics recycling, it is going to be way more efficient to start at the source, design plastics and materials that can be recycled from the beginning, than dealing with or working at the very last step of the process. That's true over, you know, all sorts of environmental examples.
Yeah, absolutely. What are our options to reduce?
I think the best place to start is looking at those problematic plastics. If you've ever been to a grocery store, you have seen a banana wrapped in plastic. You know what banana has? Built-in packaging, right? That's that banana peel. We don't need that banana wrapped in plastic. And honestly, for 25%, we're just gonna be eliminating a lot of those plastics. We don't really need to replace a lot of those materials with other things, right?
So let's say I get my birthday cake and I have the plastic dome on top of it. Is there something else that I could use besides that?
So I'll tell you the dream.
Okay.
The dream is that we move to reusable packaging and reusable infrastructure. So you get something at the store, whether it's takeout, birthday cake, what have you. It comes in reusable packaging. You bring it back to that store. You bring it to the next store you go to because they all have the same collection system. Or you have a third or fourth bin, depending on where you live, for reusables outside your house that you put out every week when you put out your trash and recycling system. It needs to be as easy and simple to reuse as it is to landfill or recycle.
Yeah, absolutely.
The challenge that you're talking about, though, is that ongoing challenge that packaging design engineers at all of these different brands and all of that are wrestling with right now. And so they're working through trying to determine what are my options in terms of being able to make sure that I can protect the product that's included, because the least sustainable package is the one that fails before the product gets to the consumer. The other thing, too, is you need to make sure that the product is well protected from like a shelf life standpoint. And so let's not over-engineer packaging that doesn't need to be to offer that really, really extreme, let's say, oxygen barrier environment that doesn't need it. The other part, though, too, that comes into this is going to be cost. And that's not something that we can completely leave out of the equation here, and trying to figure out how do I produce a package that can do what I need it to do to protect the product, because generally what's inside that product has a much more significant greenhouse gas emissions impact. So again, the least sustainable package is the one that fails. But like Anja said, trying to figure out how do we shift to reuse models. Americans, we love our convenience. There are huge opportunities for this, but we also are going to have to look at the implications and the costs that go along with some of the refill and reuse systems and get there gradually over time.
I'm so glad Holly brought up cost. It's very cheap to make that packaging, and producers don't have any economic incentives to make it recyclable if that costs more money, or put less packaging on it if it could potentially endanger a product. You know, they're going to err on the side of over packaging.
So this kind of gets into the policy realm then, right?
Exactly. So what extended producer responsibility policies do is that they require producers to pay for their specific products, recycling, collection, you know, end-of-life management. So if you are making a styrofoam product, which is extremely difficult to recycle, you are going to pay more than someone who's making an easy-to-recycle plastic water bottle, for example. That realigns these incentives, so they're finally pointing in the direction that we need for our planet. And we've seen these tried and tested throughout the world, and we do not see prices skyrocket.
Interesting. I mean, my mind's running in good directions and challenges.
We have extended producer responsibility policies already in the US for other materials that are difficult to manage. Pharmaceuticals, mattresses, carpet, batteries even. We are used to holding producers accountable and saying, you helped make this, you have to help pay for its end of life.
Neither of you mentioned alternative materials to plastic. Are there some?
Of course. If you look at a lot of the different options, you'll see some reuse or refillable packaging, and models that are out there are using glass or using metal. In certain environments, glass may not be preferred due to a safety issue. In some cases, metal may not be preferred because consumers want to be able to see the product on the inside. So again, it's just always trade-offs in terms of design, but those will continue to evolve.
When it comes to alternative materials, there are absolutely options out there. What we want to avoid is this one-to-one replacement. We don't want to get caught in this cycle again of take, make, waste. You know, it doesn't matter the material type. If we are in that linear life cycle, we are going to run into trouble.
Yeah, got you. Well, terrific stuff. I've learned a ton. Final thoughts, you know, what are 2 or 3 main points you would like to leave with?
First, plastics are fossil fuels. We cannot tackle our climate crisis without tackling plastics, and we know that the plastic pollution we see in our ocean or on our beaches are just the tip of the iceberg. Behind all that plastic is a whole bunch of additional greenhouse gas emission pollution. Second, when it comes to solutions, we are long past time of this being an either-or decision. We need to reduce, we need to recycle, and we need to clean up what's already out there to prevent future harm. This is a all-hands-on-deck moment. And lastly, to end with a note of optimism, there's still time to turn this around. Half of all plastics ever made have been made in the last 20 years. That's our lifetime. We still have time to move the needle on this issue if we act now.
Yeah, probably all the plastics in the world been made in my lifetime. Final thoughts.
So I think one of the big things that I think is important for everybody to remember is that plastic recycling is not a myth, is that it's happening today, but we could absolutely do it better. And as we look at this, looking at infrastructure improvements, looking at technology additions that can add complementarity and additionality to the system are going to be critical so that we can create viable end-of-life options for material and keep these molecules in loop is going to be absolutely essential. The other area that I think is important, and Anja had talked about this earlier, is that we really need to improve the transparency in this space and really help to try to indicate and share more information about different chemical recycling technologies in particular. What are the greenhouse gas emissions? What are the efficiencies associated with them? And what are our options to be able to start to demonstrate impact on local communities, how we're managing environmental justice concerns with these technologies, because we see this as a critical way for us to displace some of the fossil fuels that are being used today in materials and really create high percentages of recycled content. And as we keep working through this with extended producer responsibility, being able to, you know, sit at a table with Anja and have conversations and better understand her concerns and start to figure out how we can address them is going to be really critical as we start coming up with ways to make plastics truly circular.
Yeah. Well, I've learned a lot. Appreciate your candor and openness and your experience and knowledge on all these things. So, Holli, thank you.
Thank you so much,
Thanks for being with us. Anja, thank you.
Thanks, Scott.
Scott Tinker, Energy Switch.
Plastics require about 3% of our oil and gas and make about 3% of global CO2 emissions. They make millions of products, lighter and cheaper than metal or glass, which makes them hard to replace. But the big challenge is recycling single-use plastics. Many, like plastic water bottles, are fairly easy to recycle, though very few are. That's because recycling plastic is challenging. There are many chemical formulations and many recycling systems. As a result, only about 5% of plastic is recycled. Today, using mechanical methods, it's ground up and remelted. Chemical recycling that breaks down plastic into its chemical building blocks shows promise, but is currently expensive and energy intensive. Extended Producer Responsibility Policies, or EPR, which would require plastic producers to help account for its end of life, have been successful in other industries, but we all have a role to play in reducing our use of, reusing, and recycling plastic.
Energy Switch is executive produced by Scott Tinker and produced and directed by Harry Lynch. Emily Hooks is the assistant producer and researcher. Editors are Ginny Patrick, Yusef Swachina, and Jackie Kunzler. Matt Aslanian does the sound. Energy Switch is produced by Arcos Films for the Switch Energy Alliance, with support from the University of Texas at Austin,